Here in this video we will discuss about capacitance, then capacitor, then different types of capacitors, then the quantitative definition of capacitance, and also we will discuss about the different units of capacitance. So capacitance is the ability of a body to store an electrical charge and hence the electrical energy. Any object that can be electrical charged exhibits capacitance, and the capacitor is a device for storing electrical charge. Capacitors consist of a pair of conducting plates separated by an insulating material. So here are different types of capacitors. These are the different diagrams. See, this is the diagram of a tantalum capacitor. It has the advantage of their low leakage current and high capacity and long-term stability and reliability. But it is a costly capacitor. Whereas these are the different types of ceramic capacitors, and capacitance values of these capacitors are stable with respect to applied voltage, frequency and temperature. That means the capacitance value does not vary with the variation of voltage, frequency and temperature, and these are of small size and can survive high voltage. And these three are the diagrams of commonly used capacitors in our ceiling fans, and these are the low cost capacitors. Now let us discuss the quantitative definition of capacitance. Capacitance is the measure of extent to which a capacitor can store charge. We already know that for any charge distribution, the potential is directly related to the charge of a conductor or charge of the body. Even for a point charge, see, the expression of the potential is some constant. For air medium, this constant is 1 by 4 pi epsilon naught, some constant into charge divided by separation. This is the expression for potential for a point charge. See, with increasing the charge, the potential also increases. So let us write this here. If we supply charge to a body, its potential increases or rises. More the charge, more will be the potential with certain limitations. Now let us write this mathematically. If V be the potential of the conductor due to charge Q given to it, Q given to it, then see, Q is proportional to V. As with increasing Q or charge on a body, the potential increases, so Q is directly proportional to V. This implies Q is equal to some constant into V. Here this constant of proportionality C is called as the capacity or the capacitance of the conductor. This constant of proportionality here, capital C is the constant of proportionality and is called the capacitance of the conductor. So from this expression that Q is equal to C into V, write this as equation number 1, we will get the capacitance C is equal to Q divided by V. Let us write it as equation number 2. So the capacitance of a capacitor is defined as, so it is a quantitative definition of the capacitance. So it is the ratio of charge on the conductor to its potential. So let us write this, the capacitance of a capacitor is defined as the ratio between the charge on the conductor to its potential. So this is one definition, or we can also define it in other way. For example, if we can define the capacitance in other way also, that is, if in the equation 2 V is equal to 1, then if we take V is equal to 1, then C is equal to Q, then C is equal to Q. So the capacity of a capacitor is also defined as charge required to reach it through a unit potential. See, V is equal to 1, so it can also define as the capacitance of a capacitor can also be defined as the charge required to reach it through a unit potential. So these are the different definitions of capacitance with the diagram of different types of capacitors.